poles, the shift of the continents, etc. The other theory is what's known as the planetary expansion model. And we need to stop and go back to my idea that we're all energy beings, right? We're all trucking around vibrating as standing waves of energy. Well, what are we standing on? We're standing on nothing that is solid. We're just standing on another form of a giant standing wave, which is the planet Earth. It's just a huge, giant toroid that's collecting and spewing energy for all it's worth. So it kind of makes sense that even if you were to take Einstein as being accurate, or even pre-Einstein stuff, where we say that energy and matter cannot be destroyed; they can only be converted from one to the other in our particular universe. Well, here's our situation: we're standing on this mass of energy that we call Earth, that we think of as matter, and it's receiving all kinds of new energies out of the sun that it hasn't had in these past 50, 80, 100, 200, 5,000 years. And it's got to do something with those. So maybe what the Earth is going to do is to take those energies that are zooming right into the middle of its toroid, which is basically the middle of the planet Earth, and maybe it's going to create new matter. And maybe that's where magma, our core, comes from, and so on. Bear in mind, the core of the planet Earth is not molten iron. That's a bunch of hooey. That's so far wrong. It's down there with the Flat Earth Society guy. The core of our planet, if it were iron, by the way, first off, no molten metal, even in a hyper-accelerated state, can be made to throw a magnetic field. We haven't been able to achieve it. It just does not happen. So there's no way that the magnetism that is the Earth's magnetosphere could be created by a spinning chunk of iron in the middle of our planet. Now, it could be created theoretically by iron that was frozen. Once iron cools, or metal cools, it can take a magnetic charge. It's just that when it's hot, it can't. Okay. Or it can take the charge, it can't express it. So once the metal cooled in the crust of the Earth, theoretically that could provide the magnetosphere. However, science argues against that because our magnetosphere fluctuates constantly, and we know there's not enough metal in the crust to produce the level of magnetism that we see exhibited in the Earth. So what's the other alternative? Well, plasma, that is to say super excited energy, throws off a magnetic field like nobody's business. And so it makes a lot of sense that the middle of our planet is in fact plasma. And that plasma is basically, you can think of as just like really hot gases. Or actually what it is, it's energy in the process of becoming matter. So the sun throws off all this energy. It goes down into the middle of the toroid that is the planet Earth. Planet Earth says to itself, well, geez, I'm big enough, or I got all this stuff. I got to do something with this energy. And so it starts converting it to matter. And in the process, that's where we get oil percolating up through the crust and all of this, as all of the finer levels of molecule that are instantly created, the hydrogens and heliums and so forth, gradually become denser and denser and denser and clumped together as they are pushed out towards the crust. But you can imagine in such an idea that it would be theoretically feasible, and in fact a natural extension of that theory, that the Earth could expand itself. If it got a big burst of energy from the sun and it didn't know what to do, it would just create a bunch of matter, and it would expand from the inside out. So that theory still has validity, because that theory would say that when it expanded enough, the equatorial bulge would crack and disappear. Different process, but nonetheless would flatten out. That theory would also say that at that point, the continents could go spinning around, just like in the other crustal theory. Plus, the planetary expansion model has one other thing going for it that is just cool as hell. And that is that if you were to take a globe, or a giant spherical paper map of the Earth, and you were to take some scissors and carefully cut along all of the coastline and remove all of the areas that we think of as the water, the ocean beds and so on, you would notice something, that all the continents fit together. Right. Okay, they snug together, but the size of the sphere is 60% smaller. Okay, so it is quite feasible that we started out 60% smaller, and over the course of time, we got all these expansion incidents, and we expanded. And what would happen in those situations? Well, you'd get a crack in the space between the continents as new matter is shoved up, and they would get shoved further apart. You'd get uplifting earthquakes and so on. You'd get volcanism. You get lots of little holes in the sphere spewing out this new matter, which of course creates further pressure and shoves the continents further apart. Okay, and so and what do we have on Earth now? Well, in the middle of every damn ocean, running between all the continents, is a big crack,
Right.
from which we get expansion in the form of volcanoes and all kinds of stuff. There were a bunch of people up here at the U of W, University of Washington, that like in, I think it was 69 or 70, had some ideas that eventually got funding, and in the late 80s they sent some ships down to the South Pacific looking for specifically for a volcano at a specific spot. Because if they found this volcano under the sea, they figured that would be an evidence that indeed some of the expansion issues were more than theory. Well, they go there, and instead of one volcano, they found 11,000 volcanoes. And so, well, duh. And here's one last little capper on the whole thing. No geologist on the planet can point to any part of this planet and prove that subduction is taking place. And subduction must exist if the tectonic plate theory is accurate. And since we do not find subduction, we find something that is only inadequately explained as a subduction event and could in fact be explained much easier as part of the expansion process. So whenever they say that this plate is subducting under the other plate, that's mostly bullshit, simply because if you go and actually examine the data of what's going on there, they don't have any of the follow-ups to subduction. So in other words, if, for instance, we actually had subduction occurring at the San Juan de Fuca plate up here, where theoretically the Pacific plate is going underneath the American plate, then there would be a whole lot of stuff going on that does not occur. We have volcanoes here, but any place you have an active subduction fault must, by its nature, grind down matter to the point where it becomes liquid, hot, and magma again, and you must have volcanoes spewing out all over. What we actually find is the reverse. Every place that they say is a subduction event, you don't have volcanic venting. You only find volcanic venting where there are these boundary cracks between what we think of as the plate areas. And those boundary cracks are only on the sides of the planet where expansion is taking place. And we, by the way, if we were to have a subduction, we would never see the planet expand. And that is measurable now that it's actually occurred over these last 5,000 years. We actually are able to say, you know, that, what's his name? Some of the Herodotus in, I think that was him, in ancient Egypt, did some fantastically good mathematical work and came out to a size of the planet, which we now say is off by 0.1013%. Well, maybe it wasn't off by 0.13%, because if you use his same mathematics today, you get an accurate representation of the planet's size. And if he used that same formula, maybe the planet actually was smaller at his day than it is at ours. And there's all these various different examples, including physical geology, that point to the and support the idea of the planetary expansion model. And we see it on other planets as well. So, excepting moons, which is an interesting issue. But in any event, so at this point, I'm thinking that maybe what we're about to see is a modern, or is a human species living through an expansion event.
Well, and let's say one of those two theories are correct, or both potentially. How fast could we potentially see continents moving around? Is there any way to tell? Or
sure, we actually have historical records. If you want to go into some of the French and Belgian translators of ancient, what we call Egyptian, but in fact is Atlantean records, we get a situation where we have people that have translated these records that are found in the western edge of Africa in sites that are no longer accessible by any of us because the powers that be control them. But you find temples and stuff that describe what it was like to go through the last crustal shift by the people that we call the Atlanteans. Okay, and their response was that it occurred thus. There's actually this really cool ancient text, and I'm trying to, there's a fellow in Europe that's sending me a copy, some pages out of a book. That the book is fantastically expensive. But he happened to have a copy, and he's sending me the original text. I'm going to do my own translation of it. But
right.
So far, I trust the translation I've been given. And that translation is from a sea captain that took he's actually more of a commodore because he controlled several boats. But he took a group of people, sailed them from what was Antarctica up to the Azores in the process of the of the last pole shift. And then when it was all done, he took all the survivors from the Azores and landed them on the western edge of Africa. And then they wrote their story down at some point and put it in these structures there commemorating everything. The structures also served dual duty because it looked like they were set up to determine what the new planting seasons were, the change in the orbit. There was a lot of math involved that seemed to suggest that they were dealing with a shift in a number of days in the orbit, which of course also goes to the expansion model. As an aside, as the Earth expands, it will alter our orbit, adding days as we go along for a variety of reasons we needn't get into. So it makes sense that we went from a 360-day orbital period to a 365.25 or period. Okay, so anyway, the description of this is as follows. They get on their boats, and it's about dusk. In their time period, about 5 hours of very disturbed, choppy seas threaten their fleet. In the 5th hour, the stars fall. By that, they mean that the stars go whizzing about in the sky in this big jerk that took about 45 minutes.
Wow.
So for about 45 minutes, they find themselves accelerating along with the wind. They have no control. These are sailboats. They can't steer unless they have greater speed than the winds and the waves in which they're in. And so they had no control, and they were just more or less bobbing along for about 45 minutes as all of the stars appeared to descend to the south, which meant that they were actually rotating to what we think of as the north. Then there was a period of quiescence that lasted also about 45 minutes, and then another great jerk. Then there was a period of quiescence that lasted for several hours, and then another smaller, lesser jerk, and they found themselves with the planet and basically the organization of the continents that we now have. And so it occurred in 3 separate jerks, not a smooth continuous motion. The jerks were violent. When you were in the middle of them, it was kind of okay, but when they started and stopped, it wasn't all that pleasant. But in the main, they did okay, and in the main, the guy was able to bring through most of his fleet. They had about 30 to 40% of the boats that were dismasted and made unmanageable and later on had to be towed. They lost a couple of boats, and they had a couple of boats that were swamped, and they were able to recover the people. All of this is detailed in their description of the events and all of that.
Well, fascinating stuff. So potentially we're all in for a heck of a ride here in the next couple of years, huh?
Certainly, we're not potentially. We will experience a hell of a ride. Whether we get to the point of a crustal shift is it's really hard to say because there are a couple of things we need to note. Okay, one of the things is that in 1947, the U.S. military had an expedition going down into Antarctica.
Okay.
At the same time that they had that expedition going, Admiral Byrd's expedition is, the same time that they had that expedition going down into Antarctica, which a lot of people were killed, by the way, and it was very mysterious and probably involved Nazi bases and all of that. But at the same time, they sent a bunch of people flying over the North Pole to try and determine the exact mathematical and magnetic position of the pole relative to the geographic pole. Okay, they did that to supply information to Admiral Byrd, but they also ended up with this interesting bit of information that came out of that. The interesting bit of information was that any time in our past that the magnetic pole and the geographic pole lined up exactly, we have had a crustal shift. Okay, this is information that Hapgood did not have. He had some of it, but he didn't have the confirmatory stuff that came out of the military. So, because